All right, so we've calculated some centers of mass, and I want to actually show you some actual physical objects here. Here's my favorite region, y equals x squared, and we calculated the center of mass to be at x equals a half, y equals 2/5, so that's 0.4. So the spot's right there, right? And that's all fine and dandy until you say it balances there. So what I've actually done is I've taken a 3D printer and printed this region. I also printed the grid on there so you can see that it fits in to the grid. These are 2 centimeters across on each of these squares here. But this is the center of mass right there, which theoretically it should balance if I were to do that. So I can pick it up and put my finger on it here, turn it over, and sure enough, it balances on that point. It should be able to balance like on, I could take this pen and put it on that spot, and it should balance on that pen, but it annoyingly doesn't. And so the thing is, it works on my finger because my finger is a little bit bigger, and it's still center of mass is on it. The calculation that we did assumed uniform density. And I printed this thing with the grid lines on it. So it's thicker where the grid lines are and thinner where the grid lines aren't. So it's not uniformly dense, which may throw that center of mass off by just a little bit, which means when I stick my pen right there where the center of mass should be, it's actually not there. And as soon as you're not holding it up by the center of mass, it says, oh, sorry, I'm not going to stay up. But anyway, it doesn't move it off by much. So when I put my finger on it, the center mass is still over the tip of my finger somewhere, and it does balance. And I printed a couple other regions too. Here's one that it's got like a cosine curve on the bottom and a big sine curve on the top. And you can see that dot right there. That's the center of mass. And this one, I think, balances pretty well. If I get a fuzzy tip pen, so it's not too slippery, and I put it right on that thing and say go. It's like, yep, it balances. Of course, you can't see whether I'm really it's tipping. But yeah, it's pretty close to the balance point there. This one I did not print a grid on, front or the back. You know, it's all just flat. So the idea is that this is uniformly dense. However, it isn't uniformly dense, that when you print this, it prints, oh, maybe about, this is maybe 8 layers thick, and the first 3 layers and the last 3 layers are all, I don't know if you can see the stripes on this, but they're pretty uniformly filled. But the middle 2 layers actually are these grids. It looks like this grid down here. It doesn't fill the whole thing in. It does the edges completely solid, but then it doesn't fill the middle in to save a little bit of plastic. Anyway, so this is not quite uniformly dense, and so that center is, again, not quite where we expect it to be, but it's pretty dang close, and it balances pretty well. And I have this other one too that I did that's got cosine curve on the bottom. Let's get that one out of the way. Cosine curve on the bottom and a bigger sine curve kind of thing on the top. Center of mass is calculated right there, and if I hold it by that point, yay, it balances. Right. So yeah, these are actually the balance points of these regions that we're finding. It's amazing how sensitive that assumption of uniformly dense is. If it's not uniformly dense, then that delta that you got to throw into the equation, into the integral, will throw that answer off by even a little bit, and then it, where you think it might balance, it doesn't. You got to get it right. So anyway, thought you might like to see those 3D printed regions with the centers of mass marked on them. There you go.